That's right. Hello and welcome back from that delicate break. I hope all of you are refreshed. And now we're going to proceed with the next segment of our conference. Ladies and gentlemen, it's an honor to introduce Dr. Fereidoon Moghadas Nejad, a distinguished scholar in civil engineering. With a PhD from the University of Sydney, he has made significant contributions to transportation engineering as the head of the Transportation Division at Amirkabir University of Technology. Dr. Moghadas Nejad is among the top 1% of researchers recognized for his groundbreaking work in pavement engineering. He is also a valued collaborator in numerous national projects, demonstrating his commitment to advancing the field for the benefit of the society. With well over 240 journal articles, 210 conference papers, and numerous awards, including the highly cited researcher recognition, his impact is profound. Please join me in welcoming Dr. Moghadas Nejad. And I would also like to invite Professor Funk and Dr. Khalu for the conference chair to be here and honor us with their presence. Please put your hands together for Professor Planck and Dr. Khalu.
Okay, thank you very much. I would like to express my gratitude to Scientific Concrete Society in general and my colleague and friend, Professor Khalu in particular, for inviting me to present my research in field of the actually concrete pavement repair and maintenance using artificial intelligence. In last 5 years, we have started in Amirkabir University of Technology using artificial intelligence or AI as a tool in the field of research for transportation infrastructure systems. And this presentation is part of our series of research in the last 5 years, actually. All right. Okay. As you can see in this figure, I'm going to talk about the optimized faulting prediction using artificial intelligence. First of all, I would like to actually explain what do I mean of regarding the optimal faulting prediction, and then I will talk about the artificial intelligence and its application in prediction of faulting de-stress. Okay. First of all, I want to introduce the faulting de-stress, what this means, then concept of faulting failure, then a little bit regarding the researcher review and the methodology we use using AI as a tool, and finally result and discussion and conclusion. As you can see, transport infrastructure behave huge part of the actually budget in each country is consumed for the actually transport infrastructure, and paving the main part of the transport infrastructure in every country like Iran. That's why it's very important to think about that, to research about that, because of this huge part of the actually budget which can be paid for the infrastructure, transport infrastructure. Today I'm talking about the JPCP and the failure of the JPC as a actually faulting. What is faulting? As you can see, faulting the difference between height of the two adjacent pave slab, as you can see in this figure, which is very important. I want to talk about how this stress is going to happen and how we can predict this one, and in order to prevent or in order to repair this part of this kind of actually de-stress. As you can see, when the wheel or vehicle wheel comes toward the joint, you got tilt down of the slab when the tire approaches the joint. Because of the tilt up, you got the pumping of the mud and water from the joint to upward. After a few thousand cycles, the result of this problem would be resulted in actually the difference between the elevation of between two adjacent slabs, and finally we have difference between the height of these two slabs, which cause some problem regarding the user and confidence of user when it goes through the joint. Okay, we can see literature. Most of the research regarding to prediction of the faulting, they use the regression analysis. But recently, in last few years, most of researchers using, for example, artificial machine learning, deep learning, and such as artificial neural network. That's why we try to focus this artificial neural network as a tool in this research in order to see but we can predict this problem accurately or not. Okay. In order to have some data to use this technology, we need actual data. In order to find some data regarding in order to use to our project, we use LTPP, long-term pavement performance. It's a huge bank, a data bank which is located in United States. We use this data in order to verify the methodology we use in neural network to predict the faulting DSLSs. Let me talk more about the LTPP. Location number of the pavement throughout the United States, you can see this actually marks. This location we use pavement which were built in the United States, and we use the data in this location in order to verify actually the methodology we use to predict the faulting. The data collection consists of 32 variables. For example, size with little size, the annual average number of the days, cumulative number of the days in which freeze-thaw cycle occurred, the annual average number of the days when the temperature is higher than 32 degrees of the centigrade, and so on. As a whole, we got 32 variables because we believe this variable can affect the faulting in the concrete pavement. Totally 32 parameters. We collected these parameters from the LTPP in United States. Across the United States. Okay, but the question was how many of these 32 parameters are more important in order to affect the result of the faulting? This is the main question. That's why first of all, we use all of these 32 parameters to see whether we can predict the faulting with 32 degrees or not. Okay. But the problem was the scale of this variable was different. For example, elastic modulus, for example, is between 1,000 kilopascal to 35 or 45,000 kilopascal. But the SLS was between 5 and 210, for example. In order to unify the scale, we had to use this equation. If you can do this equation, we call it normalization of the data. If you can do this equation, the NI is I minus divided by I maximum minus I minimum. In using this equation, we could actually scale all of the 32 degree data, between 0 to 1. In order to add this together, in order to compare this data, we had to use the same scale. That's why we use this equation. Okay, for multi-layer perception artificial network, we use this structure. We had one layer as an input layer, consists of 32 parameters, as I said before, we had several hidden layer in artificial, actually in neural network, and output layer which had one neuron. The neuron in output failure was faulty. That's what we were looking for that. The first layer consisted of 32 parameters, as I said in previous table, but we didn't know how many hidden layers we need in order to get the best result, as well as the minimum time of calculation or analysis. Finally, we ended up with two actually hidden layers. With two hidden layers, we could get the best result, as you can see. But as I said, those of you who know artificial intelligence, the number of hidden, you not any idea how many hidden layers we need unless we try an error in order to get the best result, in order minimum error between the actual data and result of the analysis data. Finally, we ended up with two, in our case, two layers as a hidden layer. Okay. In actually artificial neural network, as you can see, we had two hidden layers. Number of rounds with 30, in our case, was 30 rounds. I mean, after 30 rounds, we could get the best result, enough result. We didn't need to continue the number of the rounds. The number of neurons was 1 to 30, as I said. Transfer function was, I am not going to talk about the detail of this actually function, but G psi method and log psi, these are two transfer function, and finally optimization method. In order to optimization, we use actually algorithm genetic. Let me talk about that in later, the other slide. Okay, regarding the feature selection, you can see the process of the actually algorithm genetic. The beauty of algorithm genetic in this case was to optimize the result. In other words, there was a combination between algorithm genetic, a particular kind of algorithm genetic, we call it MSGA2. In combination between actually algorithm genetic and artificial neural network, we could get the best result. On the one condition, the output of the algorithm genetic could be input data for actually artificial neural network. Okay. And the other method we use, parallel to artificial network, was random forest. In case of, it was another algorithm which normally people use in artificial, in AI, which is very famous and actually practical algorithm to use actually to predict any faulty, any DSS such as faulty. In the random was you got several actually trees. The result of all of these trees combined together, an average of all these actually the data trees could get the final results. Okay. In order to verify whether artificial neural network give us the best resolution or not, we try to use actually random forest parallel to artificial neural network in order to compare which one is better in order the time of the calculation and in order to find which result is better. Remind that, keep in your mind that we had two functional, actually, two function, target function, which was the first target function was the minimal data of the data of input data. How we can use the minimum data from the field, whether it 32 data is enough, or we can use the less data. This was the first object. The first second object function was to minimize the error between the actual data and actually analytical data. This was the two objective functions in order to we were looking for to find those. Actually, in order to minimize those functions. Okay. These parametric performance matrix, We use this performance matrix to check whether you got the minimum error between actual data or analytic data or not. Here it's very conventional and very usual parametric performance matrix that normal people use in artificial AI. Okay. This is the result of our prediction model. As you can see in the horizontal axis, you've got measure faulting, and in the vertical was the prediction faulting. As you can see, there is very nice agreement between actual data and prediction data, which means our methodology using intelligent AI can give you, if you use a suitable function, and if you use the suitable target function such as what I said, you can get a very nice result as you can see in this figure. Okay, in order to get this result, we divided our data from the LTP to three parts. First one, the test data. Second part was validation data, and third part was actually testing data. In order to verify the ANN as well as forest. Okay, look at this figure. It's a very nice figure. As I said, the total data was 32. But we didn't know how many data actually we need to get the same result as 32. If you can see this figure, after 90 features among those 32 degrees, we could get the same result as the 32. It means with only 90 parameters among those 32 degrees, we can get the same result as the 32. Therefore, the first output of our research, we could find with only 90 parameters, we can get the same result as we try to use 32 parameters. It's a very good achievement because if you know the main problem using the data collection is the cost. If you can get the less data from the field, it means you can collect the data at cheaper price. Once again, if you look at the table in the right part of the slide, once again you can see 32 degrees, but in particular 90 parameter was more important than others. Therefore, we try to select only 90 parameters among those 32 parameters. Okay, this is a comparison between the artificial neural network and the random forest. There is a nice nice agreement between these two methodology or between these two algorithms. Therefore, it means we can use both of these agreements in order to predict the faulting. Okay. We did some sensitive analysis using random forest. If you look at the figure, the left part of my slide, it means among all of these 32 parameters, the climate parameter was most important parameter in order which affect on the faulting. After that is a structural parameter of the concrete, and then a slab mechanical properties including elastic modulus and position ratio, and after that age, but finally traffic. It depends on which part of this data can affect on the result, which is probably the most important part of those data, and we are very sensitive to climate parameter to actually predict faulting. Okay, this is a performance evaluation between a general ANN, simplified ANN. Difference between general ANN and simplified ANN is the number of the parameters. As I said, the first, which is general ANN, we use 32 parameters. In simplified, we use 90 parameters, and also in random forest, also we use that 90 parameters, you can see there is very actually consistent and reliable R square between all of these three. It means we can use simplified neural network or for random forest instead of general ANNs, which is very time consuming and we need much more data, which is very costly for engineers to collect. Okay, this shows the actually effect of various parameters on the faulting. The CINT is the most important actually parameter than EM and ND and so on. Okay, the conclusion. This result showed we can use artificial neural machine learning, deep learning as a reliable tool to predict the problem such as faulting in concrete pavement. And according to random forest, CINT, sorry about that, the abbreviation, all the parameters which I explained in the first table, depend on the amount of the effect of each variable on the faulting. We write this one from the left side to right. And also we found that MLP ANN has the lowest ME. MEN, I mean minimum error between actually practice data and the prediction data. And according to the parameter study, change in input variable of ND and etc. have the most change in the faulting respectively. And finally, framework described in this presentation can be used for other pavement distances using LTP data. I recommend the student in the field of highway engineering, they can use this LTP as a big data bank in the United States, available for free for everybody in the world, around the world, across the world. And also, it is possible to develop a prediction model for different failures and identify the variable affecting of those failures. Thank you very much for your attention. I hope, even though I am not expert in actually artificial AI, most of them as done by my postgraduate students. I want just explain a little more about the technology and also the result of our research in Amirkabir University of Technology. Thank you very much.
Thank you for a nice presentation. Please stay. We have time for one question.
Sorry.
Is there a question from the audience? There is one over there.
Hello, dear professor. Thank you for your great speech. I would like to ask you about a question about how many samples did you use for this particular subject?
Actually, as far as I remember, it was 192 samples.
192.
Across the United States, yes.
Okay. As you showed in your figures, I saw that measured faulting less than 5 was perfectly generalized by regression lines.
Sure.
But more than 5 was not actually, I think the differences between actual data and predicted is for more than 5. Do you think that...
What do you mean by 5? I didn't get you. What do you mean
in
by...
the figures, the horizontal line was measured faulting. If it's possible.
Sorry about that. Yes. What do you mean this one?
Yes.
Okay. Ask me please the question.
Do you think that with ensemble learning, can we train a model for more than 6 measured faulting to predict more efficient and then ensemble them with
I don't have any idea regarding that. It depends on the quality of data you got. You know, I do not have any idea how this data is qualified or not. The only benefit of this data because it was available for free to use Not only in this research, many of our papers we have published so far, we use this LTPP as a data, very beneficial and suitable data for Ferid. I do not have any idea how many data can. In our case, as I said, 192 data was sufficient to get the result.
Okay. Do you think that ensembling 2 or 3 or more other algorithms can help?
Sure. We got several papers regarding this application of this method. I will be happy to give you those papers in order to study about that.
Thank you very much.
Thank you very much. Any question? Okay, thank you very much.